Hello everyone, hope you are doing well. Welcome to my YouTube channel. Today I'm gonna show you how SSH works and how you can connect remotely to another computer on port 22, or SSH protocol. This is my first video on my YouTube channel. I would appreciate if you subscribe to my YouTube channel and like this video if you enjoy it. So let's jump into it. The first slide is about what SSH is. SSH or Secure Shell is a cryptographic network protocol used to securely access, manage, and transfer data between computers over an untrusted network by providing encrypted communication, authentication, and data integrity. It replaces older, insecure protocols like Telnet and R-logging. So, you may ask this question, why Telnet and R-logging are not safe? The reason Telnet or R-logging is insecure because it sends all data, including usernames and passwords, in plain text over the network. So anyone sniffing the traffic can read it. So let's say someone become the man in the middle, and using some tools like Wireshark, they can steal or capture all of your information like username, password in plain text, and they can access the website or uh, the account that you have on a website or a specific web application on your computer by entering your password and username. And yeah, because the whole password and username are transferred in a plain text and they're not encrypted. Encrypts commu encrypts communication between two machines to ensure privacy. This is what SSH is in a nutshell. The next slide is why SSH exists. Why do we need to use SSH? SSH exists to provide a secure, encrypted way to access and manage remote computers. So, if you want to access to another computer remotely and securely, you need to use SSH, which usually is port 22. Protecting data, passwords, and commands from being intercepted. So some protocols like Telnet or R-login, which if I'm not mistaken, Telnet is on port 21, vulnerable to network monitoring and credential capture, but SSH ensures secure authentication for remote access sessions and created to provide to robust confidentiality and integrity. The next one, how SSH works. The first step is client try to initiate a communication or connection to the SSH server. In order to initiate this connection, a SSH server should be running on the server or on your target computer. If there's no SSH server, you cannot do SSH to the computer remotely. So you need to have SSH client, which is you. You need to have installed SSH on your computer installed, and the target or the remote computer needs to have SSH service installed and be running on that port or 22, or it can be different port, but it's rare. The second step, once you try to connect to the target remotely, a secure encrypted tunnel is established between the machines. So it's a secure tunnel that you can transfer data like username, password in encrypted form, not in plain text like Telnet. The final stage and the third stage is all commands, responses, and all file transfer happen inside the secure tunnel, which is not visible to anyone but you. Port 22 and SSH daemon. The first thing, by default, SSH listens on TCP port 22 for incoming connections. Second, on Unix-like systems, the server runs as a background service called SSH. If you are using macOS or using the different distribution of of Linux, so you can use systemctl start or enable sshd.service command. It enables and starts a SSH service on your computer immediately. So, the third one, remote login activation. Enabling remote login on macOS or Linux starts the SSH listening process. So it's like you start a SSH service on your computer, and as soon as you start SSH on your computer is ready to get any connection from other users remotely. But there are three conditions that someone needs to have in order to connect to your computer or connect to any remote server or computer remotely and securely. They need to have your username, the username of your computer. They need to have your private IP address or public IP address, uh, depending on your situation and location. Okay, so if your computer and the server are both in the same local area, you use private IP address. But let's say you live in the United States and the server is in the Germany. You need to use public IP address, which is specific for that server. Okay, that's the whole point. You need to have password, username, and the IP address of your target. If you don't have one of these things, you cannot SSH to the target system. In some cases, you can, after gaining access to the target computer, you can implement public key or SSH key in order to not re-enter the password every time that you want to SSH to that computer, which is way more secure than entering password every time. So, but for the first connection, you need to have SSH password for the target computer. And after that, you can implement public key or SSH key in order to connect to that computer automatically, and they authenticate you using that key. SSH authentication method. SSH supports multiple authentication methods for system access. Commonly utilized password-based authentication. Public key authentication offers significantly higher security levels, as I just told you, because you don't need to re-enter your password or the target password each time that you want to SSH to that target, which is it prevents some like keylogger if someone has implemented keylogger on your computer. So after you're done with entering the password, they can easily retrieve or fetch that data from the keylogger malware that they have implemented on your computer, and they can know what password you have entered for that remote computer to SSH to it. So public key is way more secure. Key-based methods are resistant to brute force attacks. SSH key agreement, establishment a shared secret. The first stage is client and server generate a key pairs, but both try to share and transfer public key, not private key. Private key, as it's obvious from its name, you need to keep it safe for yourself and do not share your private key with others. The servers try to transfer its public key with the client, and client tries to transfer or share its own public key with the server. And using this public key exchange, they send only public keys client public key to server and server public key to client. Compute shared secret. Each combines its private key with the other party's public key to produce the same shared secret. Let's say you are a client and server sends you a public key. It's a public key, okay? You use your own private key and server public key to generate and create a shared secret. And then using this shared secret, you generate symmetric key. What is symmetric key? Using this symmetric key, you decrypt and encrypt the data. That's why this data is secure and it's not visible to anyone. So you may ask, what if someone else tried to create their own private key and generate a shared secret key using the public key from the server and its own private key? You need to note that if someone like a hacker try to do that, they get different shared secret and they won't be able. So since they get different shared secret, they gonna get different symmetric key. So they're not gonna decrypt or encrypt the same data that you have on the tunnel or in this communication. So they're not able to decrypt the data. And the fifth stage and the final stage, encrypted tunnel active. All commands, password, and file transfer are encrypted with the symmetry key. If you're an iOS developer or if you're familiar with Swift, it should be very straightforward to you. But if you're not, don't worry, don't panic. I'm gonna explain to you how it works. So this is my private key, which is me. And using that private key, I have public key. So I have a public key and private key. Let's say server has its own private key and it shares its own public key with me. Okay? And then on my side, I try to use my own private key, which is my private key, and server public key to generate or create a shared secret. And after using this shared secret, I try to generate a symmetry key, which is here. Using this shared secret, which is created by my private key and server public key, is gonna be this. It's gonna be the same when user use its own private key and my public key to generate the same shared secret. So, if a server use its own private key and my public key, it generates exactly the same shared secret that I generate here with my private key and server public key. It's gonna be the same shared secret. And since we have the same shared secret, so we have the same symmetry key, and it's really easy and straightforward for both sides to decrypt and encrypt data. That's the whole point of encryption of SSH. So there are many ways. P256 is one of the ways that you can make your connection secure and encrypt or decrypt data. There are various things. P256 is not the only way. There are some other methods like Chachapoli or something like that that you can make it more safe. But it's way more advanced, and it's not the purpose of this video. The purpose of this video is just show the basic and the foundation things of SSH. So yeah, this is the summary of what we just explained: private key, public key, and verification, which is the same thing. Okay, SSH a process. Okay, we are done with the theoretical thing, and let's jump into practical thing to gain some knowledge how it works in real world. So in this video, I'm just gonna explain about the Unix-based system like macOS, Darwin, or Kali Linux, or any Linux distributions, no matters. So let me go here and open my terminal, make it bigger. So as I just explained, in order to SSH to another computer, a SSH server should be running on your target. If there's no server running on your target, you cannot SSH to that computer. Besides that, in order to SSH to that computer, you need to have three parameters: username, IP, and passwords. So let's say my Mac here, let me close it. My Mac here is my target, okay? By default, the SSH service on Mac is disabled, so you should enable it. But how? You open your settings, go to General, and go to Sharing, and there's a section named Advanced, and this is the remote login. Okay, this is the remote login, and as you can see, by default, it's toggled off. As soon as you toggle it on, the SSH server will run on your computer, and anyone who has your username, passwords, and IP address can easily connect to your computer and access all the folders and all the content of your all the content of your systems if they are allowed and they have the permission. Okay, I will talk about it later. So let me go here. If you want to know what the IP address of your Mac is using terminal, it's so straightforward. Let me show you how it works. You open your terminal, you make it bigger, and you say ipconfig get if address EN1. This is your private IP address specifically, and is a private IP address just for your machines and for your device or your computer. And if you are not sure what interface your computer is using, the only thing that you need to do is just go up here on Wi-Fi icon. Before click on that, press Option key and then click on that. And as soon as you click on that, the interface name and also your private IP address, which is the same thing that we got here, is are gonna be visible to you. Okay, yeah, this is the interface EN1. That's why I enter EN1. You might have a different interface name, so be careful about that. So let me scan my IP, which is this. Let me copy that and go back to my attacker machine. So the first thing that I want to know, so the information about my target is kind of ambiguous or vague for me. So the first thing that I need to know is if there is any SSH service is running, if there is any SSH service running on the target computer or not, or because if I want to try to just SSH to that computer and there's no SSH service, server running on that computer, it's just wasting the time. So the nmap is not just the purpose of this video. I want to remind that it's just gonna be a quick reminder or review. So I use nmap ss and use the IP address the target system of the target system. So nmap tries to scan the first 1,000 ports, and as you see, so yeah, there's no SSH open here, doesn't matter. 999 ports are closed on my computer. So what it means it's gonna be useless, and there's no use if I want to try to SSH to my computer. Even I have 3 parameters: username, IP address, and passwords. There's no use, okay? But let me clear. If I go back here and toggle it on, I explicitly allow my computer to run SSH server on my computer. Okay, now there's a door named SSH on port 22 open in my computer. Okay, so anyone who has the 3 parameters username, password, and IP can easily access to my computer. Okay, if I go back here and run the same command, the SSH protocol on port 22 should be visible to us. Yeah, as you can see, the previous scan just showed us this port, which is unknown, this unknown service. But now, as soon as we toggle that option remote login on, we now have SSH server running on the target system on port 22. So now, by having the username, which is this part is host name. If you are a Mac user, the second part is host name and the first part is username. By having password and the username and IP, you can easily SSH to the computer. So let me go back here and I use SSH. The first thing you need to enter is SSH command. Okay, then the username, which is Milad Randy, and then @. After @, you need to use IP, which is 192.168.121.29. If I'm not mistaken, yeah, it's the same thing. As soon as I enter, it asks me to enter the password of the target computer, which is that. Yeah, I enter the password. You see, I am now connected remotely to the target computer. How I know? PWD is I'm in the Milad Marandi directory, home directory, and if I ls, I have access to the all library. But it's specifically and it's only for the Mac OS. As you can see, if I ls to the all folders, You can see for some directories, specifically for the main directories, we have plus here, which is for ACL or access control list. Even you are the root or the administrator or admin of your computer, Apple and macOS has restricted some applications to access all the folders and data. So let me go here. I go to CD desktop. I CD to desktop, okay? But as soon as I try to ls, it gives me no permission. There's no permission. You cannot do that. You see, operation not permitted, okay? But I'm the admin. Yeah, who am I? I'm the Milad, which is the admin of that computer as long as I know, okay? So what do we need to do? If you go to settings, and let me show you here, if I go here, let me check here, privacy, full list, let me turn it off and modify the setting, quit and reopen. I'm on my own computer, okay, I'm the user. I'm trying to CD to desktop, okay, but even I'm the administrator or admin of the computer, I'm not allowed to use terminal to read the content of my desktop folder. Why? Because Apple needs the ACL or access control list for this application. I just toggle it off to show you even on our own computer, sorry, we need to give the permission to these applications, which is terminal, to allow it to read the content of the critical folder like desktop, downloads, or something like that. Let me toggle it on, quit, okay. It's gonna reopen it for me. But I just gave the permission for the terminal to be permitted and to be allowed to read the content of the critical folder like desktop. As soon as I ls, now I can read. So should be fine? No. Because if I go back here and try to ls, I still get the permission denied. You see? Because the macOS protects desktop documents and downloads via TCC, which stands for Transparency, Consent, and Control. TCC only allows apps that are granted full disk access to read these folders. SSH sessions and remote users are not considered apps in TCC. So by default, they don't get permission even if the user is the owner. So what's the solution? If we come back here, go back here. So let me open the settings. So by the way, if you want to change the permission of ACL, you need to go to this sidebar menu and click on privacy and security, go to full disk access and turn it off or turn it on, and you should be fine. If we go back here for the sharing, you see here, if I click on the information button, allow full disk access for remote user, it's off. That's why we cannot have access to the content of the folders, because it's off for the remote users who SSH to our computers. So what happened if we turn it on? I just turn it on. Let me, if it works now or not. Now it works because I explicitly allow the remote users to read the content of my critical folder, including desktop, downloads, and whatever. But I do not recommend you to do that. That's why Apple created a folder named public here. Sorry, let me go back. For these situations, publics. Even I toggle it off. Let me go to the sharing and toggle it. Sorry. Toggle is off, which is off. I think I'll lose. No, I didn't lose. I can go to the public folder and use ls. So it means I can read the content of that file because it's public, because it's made to share with the remote users and read the content of that file. And if a remote user try to delete or do something, it won't damage our systems. It's not a very critical folder. The critical and the main folders on your computers are desktop, documents, downloads, application, and library. These are the critical and vital folders on your computer. So do not give explicit permissions to any other user than yourself. So this is the whole point of how remote login and SSH works on macOS. Now, as you can see, as you just saw, sorry, we use private IP address because we are in the same local area. So now if we are not in the same local area, if there's a server in Germany and we are in the US and we would like to SSH to that computer? I will tell you. Let me go back here and I exit. Okay. If you a cloud engineer or cloud server engineer, Amazon AWS is one of the best cloud service that you can find. So I'm not gonna show you or walk through how you can create your own server. I'm just trying to show you, demonstrate how to SSH to a remote which is not in the local area. So let me turn it on, the Kali Linux, and let me start my server, which is not in the same local area that I am. So it takes a while to get it started. Give it some time. Let me refresh it. So as you can see, for the server we have, which is the far from us, we have two IP. Every system has two IP, public or private, but it depends. It depends on the situations or the location which one we need to use. Because it's far, we only need to use public IPv4. If you try to use the private IP, because you are not in the same local area and you have different IP address or subnet mask, so you're not gonna connect it to this computer using that, so it's just a waste of the time. So the only way to connect to that computer remotely is the public IP. Let me refresh it to see the status checking. And for the service or the server, for something like in the AWS, there is a security part for security group. In security group, you need to explicitly give the permission for incoming or inbound connections to allow any SSH connection. If this part is not included, won't be included in your security groups, you cannot SSH to the server. So you should go here, edit inbound rules, and add SSH for every IP addresses, and then you can easily SSH to your computer. So let me go back here and show you how it works. It is still checking. And as you can check it on, you can go to connect, and there's some instruction that how you can connect to that using SSH client, which is the command that you can use on your terminal to in order to connect to that computer remotely. But I'm still waiting for status check. I think we should be fine. So as soon as you create a machine or image on AWS, AWS asks you to generate a public key. The public key, which is here with suffix .pem, it's gonna be the password for you. You're not gonna enter any password to remotely SSH to that computer. Sometimes you need, but AWS, in order to keep the connection way more secure, it asks you to create a public authentication key, which we just talked about it a few moments ago. to connect to that computer remotely using this public key. So if I go here, open my terminal, I go to desktop because this public key is located on my desktop. I go to desktop and let me SSH I the name of the public key that we got here, which is Kali underline Linux, Kali Linux, sorry, .pm. The username of your remote computer, you need to have that username IP, which is Kali at. We need the public IP address, not private IP addresses. Okay, so we copy that, and we go back here and we paste it and hit enter. Yes, and we are successfully connected to that computer remotely. It's that easy without entering any password, just using public key authentication. And if I say who am I or ifconfig, as you can see, we have the same private IP address as we have here. Yeah, that's the whole point of SSH to another computer. If you're in the same local area, if you are not, and the different methods using passwords, using public authentication on Unix-based system. I will post or make another video about Windows, how it works on Windows. I'm gonna publish many cool videos on this YouTube channel, how to secure your systems, how to make your application, if you're iOS developer or Android developer or whatever, safe, how to implement SSL pinning in order to prevent your application to become the man in the middle attack. So many cool stuff will be published on this YouTube channel, so just subscribe to it. If you enjoyed this video, please subscribe and like this video, and this is just the beginning. Hope you are doing well and have a really good day. Goodbye for now.